Welcome to Creative World. In this video, we will solve chapter 2 exercise problem number 2.41. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always zero. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance. Now move towards the problem. Exercise problem number 2.41. Find V1 in given below figure. This is the circuit diagram of given problem. We have to find voltage between these 2 points labeled as V1 with this polarity. We can see that this is a closed loop circuit, so we will use Kirchoff's voltage law to solve this problem. Before using Kirchoff's voltage law, first we have to assume the direction of current inside this circuit. I am assuming current I is flowing inside the circuit in counterclockwise. Now make polarity notations across resistive elements according to the assumed direction of current. The polarity notation will be according to the passive sign convention theory. Current entering terminal is positive and current leaving terminal is negative. Similar case will be with this 10 kilo ohm resistance. Current entering terminal is positive and current leaving terminal is negative. Now write KVL equation for this closed loop. Start from 25 volt. Current entering terminal is positive, so 25 volt will be taken with positive sign. Move to next element. Current entering terminal is negative, so voltage across this dependent voltage source Vx divided by 4 will be taken with minus sign. Move to next element. Current entering terminal is positive, so voltage across this 5 kilo ohm resistance, that is the product of current through it I and the value of resistance I multiplied by 5k will be taken with positive sign. Move to the last element of the circuit. Current entering terminal is positive, so voltage across this 10 kilo ohm resistance, that is labeled as Vx, will be taken with positive sign. Inside this equation there are two variables, one is I and other one is Vx, and we are interested to calculate the value of current I for right now. That's why we will replace the value of Vx with its equation. Value of Vx will be equal to the product of current through this 10 kilo ohm resistance, that is I, and the value of resistance 10 kilo ohm. Here this current is taken with positive sign because current is entering from positive terminal of this 10 kilo ohm resistance. Now inside this equation replace Vx with its value. The equation will become plus 25 minus I multiplied by 10k divided by 4 plus I multiplied by 5k plus I multiplied by 10k. Now for the further simplification of this equation, we will multiply this equation on both sides with 4. The equation will become plus 100 minus 10ki plus 20ki plus 40ki equal to 0. Now add values that include variable I together. The equation will become plus 100 plus 50ki. Place plus 100 on the other hand side of equal. It will become 50ki equal to minus 100. Divide on both sides with 50k to calculate the value of current I, that will become minus 2 milliampere. Here this minus sign is indicating that we have taken the wrong direction of current inside this closed loop. The actual direction of current inside the circuit is clockwise direction. We have calculated the value of current inside this closed loop circuit. Now we will try to find out voltage V1. For that purpose we will use this left half circuit. You may take right half circuit for the calculation of V1. In both cases the answers will be same. Start writing KVL equation for this semi-closed loop. Start from voltage. Current entering terminal is positive, so 25 volt will be taken with positive sign. Next is V1. Current entering terminal is negative, so V1 will be taken with negative sign. Next is Vx. Current entering terminal is positive, so Vx will be taken with positive sign. Inside this equation we are interested to calculate the value of V1. Place this minus V1 on the other hand side of equal to make it positive, and replace Vx with its value, that is I multiplied by 10k. Inside this equation we know the value of current I that we have calculated in previous step. Value of current I is minus 2 milliampere. So replace I with its value. The equation will become plus 25 plus into minus 2 milliampere multiplied by 10k equal to V1. Now open these brackets and take the product of minus 2 milliampere and 10k. It will become 25 minus 20 equal to V1. Solve this question to calculate the value of V1, that will become plus 5 volt. So the value of V1 inside this circuit is plus 5 volt. So this was exercise problem number 2.41. Thank you. See you again in next video.